Thanks for joining me today. In this session, we'll be looking to develop more of our super alignment elements or parametric design options. I'll introduce the computators and as just another type of geometric element and show how these can be best set horizontally or vertically to connect either a road network or other civil engineering objects together. We'll utilize some of the provided super alignment computators. I'll show you the help options that are available and some examples that are shipped with 12D model. After this, I'll also place a couple of components, provide some background information on how they're structured and how you can also manipulate these for your projects. Hello, thanks for joining me. My name's Rod Burns. I'm one of the 12D model trainers and technical support staff. There's a bunch to cover in this session, so let's just drop straight into 12D and get straight into it. So jumping into 12D, hopefully you recognize this project as one we've used before. The road down to the south here, or talking down to the south, is B01, and you can see I've already got the editor open for this one. This is just an IP designed road, so there's nothing really that special about that, but I will be manipulating that one a little bit, so I've got the editor open there. We're going to be spending more time on the little cul-de-sac street, and hopefully you've seen one of the earlier training videos where the elements were first used to build that up, basically first horizontally, as you can see in plan there, and also vertically in the section view here that we've seen. So we're going to manipulate this string a little bit more, the little cul-de-sac road here, or CO1, and just see how we can actually link the two roads together using the element method and the computators. So yes, as I explained, and I might just make it a little bit easier and turn the property boundaries off so that we can see it a little bit easier. You can see the two roads are there. There's no problem, but at the moment, if I was to move road B01 across, CO1 doesn't update in any way. There's nothing wrong with the geometry that CO1 provides, and it's been set up in the different elements here. As a fixed line, there's no problem with the way it's been set up in terms of going through the coordinate and the direction that's been provided, but it's not attached or linked to our main road B01 in any way. So we need to enhance this a little bit and introduce another part so that 12D knows to calculate the start coordinate or change this point, essentially to move it backwards and forwards so it's linked to road B01. So to do this, again, I'll just move that back. We can move it again in a minute. There's a bunch of different options that 12D have. So there's nothing wrong with this element the way that it's set up at the moment, but essentially what I want to do is come in and insert a new part. And I've basically been wanting to put in a fixed line down there so that I could find where the two would intersect. That way, again, when I move this coordinate around or move the road in this direction, that line there would essentially be those 2 points, that line would be copied or referenced, and 12D would then go down and find where the two would intersect. Now I can't just click in the box here and pick a normal 2-point line and lock those in, because again it would be looking for coordinates, and every time I move B01 those coordinates would need to shift. And this was what really led to the idea of actually using the computators. So the computators are just more parts or more elements that are available to us. You can see they're in the list here. And essentially they just replace the normal fixed, floating and free that we have. So when you expand out the computators list, you'll find the same parts. They're fixed lines or fixed arcs, you've got free arcs, and they're essentially just more, I call them Lego pieces, but essentially geometry pieces that we can click together to build up our horizontal and vertical alignment. So the computator part of it means that it'll actually be calculated. So when road B01 is to move horizontally, then of course CO1, or this fixed element, will actually update and recalculate its position again and computate its new home. When you click on the computators, you'll notice there's a little bit different that it comes up in the list here, that it actually has a little star at the end. So again, when you're looking at the elements, if you're looking at somebody else's design, horizontal or vertically, if you see a little star at the end of the element name, fixed or floating or free, and whether it's a line or an arc, if it's got the star there, then you know it's a computated element, and that part is actually doing some sort of a calculation for you automatically. Coming down, you can see the options that we have. There are many options, but you do find you use the same quite often, and the one I want to use is this reference. Reference is essentially, in my thinking, is basically the same as copying. So I'm basically putting in another fixed line that's copying the position of this line. And essentially I just need to tell it whether I'm interested in a segment or a chainage. It doesn't really matter because that fixed line is a segment. and I just need to click the right string. I've given it a direction as well, and you can see it's actually locked this in now as the first element, and it now knows about the model of the alignment and the fact that it's B01. And as soon as I hit set, the geometry will be recalculated, and you can see the geometry is coming down now to the intersection and is moving back around the intersection there. So if I move B01 again, I can move that point back. As soon as I hit the word set again, this would calculate it or computate the new answer. And again, the intersection is updated and changed to the position. So it's now locked onto, essentially horizontally, onto B01. So if B01 moves around the place, then happy days, we can just set this and get it to recalculate. Now I don't need to hit the set button each time. The other option I can do is close this panel down for a second. Just come up and actually do a recalculate. And again, this gets 12D to recalculate the string and recomputate or calculate the geometry so it puts it in the right spot there. So you can see it there. The other problem that I've got is the fact that I've added that part in, and I've now got changes that start at the start of that part. So it's actually following the line down, finding the intersection, and then coming around the corner and filling out the rest of my little cul-de-sac road. So while I want to use that geometrically, and the word here use is to say that I do definitely want to have it to use that to find the intersection point, I can actually make this part, number one, invisible. And by clicking on invisible or anywhere along here and hitting set, you'll see that that part is still being used to calculate the position horizontally, but it's now become invisible, and now my chainage starts at the intersection itself. So that's the way that we can actually link the two roads together. So again, if I was to move the point, I could come up and hit recalculate, and the horizontal geometry would update, and the chainage would now start at the intersection of the two lines where they intersect together. So that's our horizontal geometry taken care of, and how we can calculate that. Vertically was a little bit different. The way that the vertical geometry, I don't know why I shut that panel down, I probably didn't need to, but the vertical elements that we used, again, were completely 100% correct. We started at a fixed line, floated parabolas through there, and we came up with a result, and that's no problem at all. Now the points that we chose when we picked this first fixed line in here vertically was to pick the center, or the center line of B01, the other road, and also to lock in the lip of the curb. So essentially we've given it a chainage and a height, and a chainage and a height, and with those two coordinates or 2 points locked in, then 12D can calculate exactly where it needs to go and fill out the rest of the geometry. But the problem is every time that B01 moves, we'll place that down here for a minute, every time this one moves again, then obviously we need it to get recalculated again. It's going to change and move. So we need to tell 12D not to use just standard chainage and height, but actually to use the strings, which are the center line and the lip of the curb. So again, there's nothing geometrically wrong with what we've got. We just need to change up and have, instead of having just these fixed coordinates or these chainage and height positions, I'm going to say don't use that one. So I'm going to keep it in the list here, and you'll see it'll just put a gray box there to say that it's no longer being used in the calculation, but I haven't deleted it. I could delete the part, but I might want to flick it back later on or change it. Or if you're just testing things, it's a nice thing to be able to just turn them off and not use them for the moment. I'm going to insert a part, and I'm essentially going to place this fixed line with a computated fixed line. And this way vertically, it will be calculated through, again, I'm going to pick the same one. It's going to be a computated fixed line. So this time it's going to be actually calculated through. And again, we've got a couple of choices here. We go 2 points, which is exactly what we had before when we had the chainage and height and chainage and height. Now essentially 12D is going to be asking me, okay, what are those 2 points and how do we want to fix those on together? Or we might just have the center line itself and actually nominate the grade, which was fine, again, if the geometry is at right angles and you know exactly what the grade is that you want to be projecting out at. But if you don't know, we're going to build it off the 2 strings or our 2 points. So coming into the points, the first point, it's looking for the cutback and it wants to know about the string itself. So again, if I pick the string off the screen, or the center line here, it's basically going to lock in the model and the string name, and it knows that that's going to take the chainage and the height from that string there as its first point. I better set that one in there so that it remembers that answer. And then coming down the second point, again, like you did before when we picked the coordinates, I'm going to lock in the curb lip line, the KLL string there. So you can see I've locked that in there, so it now knows about the design string and the curb lip line, and these 2 points are what are forming the basically the crossfall position between those two. 12D is calculating that for me. Now it's definitely not 3% anymore, and it looks a little bit strange, and that makes sense because the road's now over here. If I come and turn on the other design models, let me just go to all favorites here and turn it on. Yes, I've moved the center line over. I've moved the center line over to this position, but I actually haven't recalculated the road. If I was to recalculate this, horizontally it updates, but vertically it hasn't quite updated correctly. It still thinks it has to go through the center line, and the lip of the curb's actually still over here. So we need to get 12D to recalculate this. And this is where essentially the chains came into play. So under the utilities chains, I've got a very basic chain or the design process set up, how you might set this up. And essentially what we would do is get 12 to recalculate our main road, or the BO1 that I've got open here. And then I'd recalculate the function that generates all the strings. So this is the apply MTF file. So the function would recalculate, and I'd execute that. And this would then reposition all the strings and give the new curb lip line its new position. Again, it's definitely not at 90 degrees anymore. So when I recalculate the side road, or CO1, that would then automatically get recalculated and produce the new vertical geometry off these 2 points. And you can see it's not 3% because of the skew angles. It's 2.6 essentially, or negative 2.6 there. So the chain can be also used, and basically I would suggest you go and have a look at some of the training on the chains. But one of the options in here is we can get 12D, similar to coming over here or recalculating the string. We can get it to resolve the geometry, and as it does that, it will recomputate or recalculate the vertical geometry for you as well. So now the two roads are essentially locked horizontally and vertically. We just need it to calculate in this order to resolve the first road and the strings. And they're important because that's going to set up the vertical geometry for our side road to then pass on to the information there as well. So that's how we would actually put the process in a chain and get the geometry to be solved. As another example, I thought we could also move across to an intersection. So I'm just going to have a look at this curb return. So I thought curb returns are probably a good way to start, just to show you how, again, the computators are used. 12D comes with some tools that it provides with computators and curb returns as well. And so we'll just build it up and sort of explain it to you and build up the different curb returns this way. So you can see the first one I'm editing here. If you were building this up, you could probably set it the same sort of way, where you'd actually have a fixed line. You'd basically parallel it or offset it a certain distance, and another fixed line, and then we'd come in between and would actually fill it in the curve with the radius that you want. So if you were drafting this up, you'd probably set it the same way. You'd parallel the two sides in, and then you'd fill it in the curve with the radius that you want. Too good. Now, again, we're using it horizontally. We're definitely using that position to form the position of where the curve gets calculated in, but we don't actually have to see that. So the little visibility here, as I said, can set that, and that makes that start at chaining 0. You'll notice that the icons do change slightly from the line with the little eye, with the line through it to say that that one's been invisible. This one's got some other markings at the end as well. So the star, as I said, is a computator. If it actually has the exclamation mark, then you know that the part or the element has actually been named. And that's useful for the modifiers in the MTF file to also name the geometric elements if you wish to, horizontally or vertically. And finally, the little hashtag there is if you wanted to leave some sort of a comment for your friend. So it's often used for things like speed examples on curves where you need to change those for a certain radius. And again, it means that any other users coming in and having a look at your super alignments, you can leave a bit of a note for them to check that out and make sure that they stick with the design rules that are set up for that project. So it's just another place where you can leave a bit of a comment or a note for yourself. So that one's pretty easy to see how it was set together, just the simple fixed and freeing it in between. So we took it to the next level, I guess, for the other side here, where we thought, well, we'd do the same thing, but having it fixed means that it's actually just set off coordinates. So if either of the two roads at the intersection were to update or recalculate, then unfortunately the curb return wouldn't update. So to build it a little bit smarter, we would actually have the same sort of idea, fixed, a free and a fixed, but this time you can see this fixed line is a computated one with the little star at the end there. And this one's being referenced, again, off the center line, which is B01. So it knows which center line it's being referenced off, how far it is to having to be offset from that. And again, being turned off basically means that it's invisible so that we don't see that. I can turn that on, obviously, and we then get that whole length of the straight where it's been fixed off that and coming up to that coordinate there. Now you can see the length here, 186. If we did want to change the start so that it doesn't start 186 meters away, we could actually type that in, because sometimes you do need a bit of a length of straight if you're trying to vertically set this in here. So we could actually add on the distance, and maybe we need 10 meters. So we'll lock that in, hit set, and that way the road would start 10 meters before the curb return, or place that into the arc there. Now around the corner, you can see I actually haven't put in another fixed line in. I could definitely have done that because we're building it off the line. But 12D also thinks about things that the fact that when we put these computators in, the geometry might change. So instead of just fixing it off the main road here and using the fixed line, 12D might also think that if this alignment was to update and possibly this curve move down for some design changes, move into this position here, then we would want to be actually calculating off a fixed arc or a fixed curve, not a fixed line. So sometimes users were getting caught out because they were looking for a line and the main road might have changed from a line in that position to an arc. So they also developed this segment reference, again, copying or referencing off a segment, and that's the one that I've used here. So the way that it works, again, it's essentially copying across onto road A01, this one here, and locking that one in. And essentially I'm just dropping a coordinate that's near where my intersection is across. Now if it happens to drop on a straight, it will reference, or it will take a copy of that segment being a line. If it happened to be an arc, it would then copy or reference an arc. So the geometry could change between a fixed line or a fixed arc, but this referencing a segment means that the segment types can actually change. Again, it's just that next level up, and it leaves you a little bit more flexibility if your design's going to change quite a bit. But it's got the same thinking in there, offsetting it and setting that up to geometrically be correct. So that's essentially another way to do it. Now, knowing this and knowing that we're going to use those same three parts each time, of course, the programmers have developed another tool. And you'll find this under the main menu, Design, Roads, More. Right down the bottom here, Curb Return, Convert to Computators. Now you will also find this option off the Roads toolbar, which I've popped up here. It's the very last one on the end here. And if you open that up, you get a nice little diagram, and it basically will build the horizontal and the vertical geometry for us. So how does it work? Well, you have to think about yourself driving down the road and around the intersection. So if I'm coming down the road and around the intersection here, then I'd pick the selecting the approach road as if I'm driving down with direction and accept, and it would lock in the B01. So it knows to use the segment and to parallel that one out. The departure, again, as you come around the corner, in my case, I'm completely upside down. So I'm coming around the corner and driving down the cul-de-sac bowl here. I'd select the departure, slide along the string and lock that string in, and it now knows about the model and the CO1 as being the string. You can change the offsets. This is how far it will offset from the main alignments that you've chosen. If you wanted to change those, maybe you've got a narrower road for some reason down the little cul-de-sac bulb, you could change those offsets, and the radius that you need also for the curb return. We can produce a label style straight onto it if you wish. There's some curb return label styles. And in terms of the name, well, the name, model, and color, I'm just going to cheat and use the same as, because essentially I want it to be drawn in the same model as our other curb returns. So with all that information locked in, I hit process, and happy days, 12D is now drawn an arc in, but it's all computated. It's a super alignment, which we can then come back in and edit. And if you have a look at the parts that the programmer's used, he again has leveled it up. He's chosen a different Lego piece again. So if we have a look at the actual elements horizontally, and you can see we've got horizontal and vertical has been calculated because the two alignments have got horizontal and vertical geometry. He's just used one Lego piece, a fixed component here, and it's a compound curve. There's other choices that we can have. At the moment, we've just got a simple fillet, but you can see there's lots of other Lego choices that we've got, and the programmers have have set in here 2-centered curves, 3-centered curves, high entry curves if we wanted to, and we'll see some of those a little bit later. But it works the same way. Essentially, it's got the fixed string coming in, and there you can see the 4.2 meter offset. So again, you're more than welcome to change the answer in here, because all we've done is essentially build a super alignment with different computated elements. And you can see there's the other string as it references on the way out. And between the two was the radius. And again, if you wanted to change the radius, we could just simply come in and hit set there. So the geometry will update on the fly, just given the geometry that you pick. If you did need to see the approach and the departure, there's some little tick boxes here to include the approach or to include the departure, similar to what we did before. So if I tick that on, it would then basically copy the string or reference off the rest of the string, and the super alignment would continue all the way around to the very end of that super alignment. If that's the case, you might also need to come in and change it so that it's not just a reference and copying the whole, referencing off the whole super alignment there. You can actually come in and reference the extents and actually say, I want it to start here, and again, put a fixed point so far down the road, and that geometry string would only be copied for that distance. So the reference extents, or EX, is just for an extents along the road if you want to. So we can break all these parts down. But yeah, if we use the standard tools that 12D provided, it kicks it straight into the elements, straight into the computators, and he even builds it with the best computators. He just goes to the high-end Lego pieces, you could say. So that's an introduction, I guess, to a component, and also leads into quite nicely into the the components. Yeah, so those computators lead quite nicely into the components. So let's come back up here under design, roads, and 12D ship some components. Essentially, they are a bunch of super alignments. I'm going to move back up to this intersection again and just show you how we can build some different operations if we want to. So 12D has these components that we can essentially just drop in different geometry, and as you'll see, they're just super alignments with elements and computators, and everything's calculated off one another. We'll start and have a look at the library first, as 12D has shipped these. Now 12D keeps working on these libraries, so if you've had used these in the past or you haven't used them for a while, you might want to come back and have a look at what's being produced or provided in the 12D library. If you wish to make your own or changes or adjustments, you'll see that it's essentially a 12D components library file. And again, we can change the name of it. Just type in an example and come down and hit write. And that obviously will copy it into your working directory. And obviously, once you change the names or fix this up with the library, if you wanted to change the names and the model names, we could then move it into the user library or your customer library if you wanted to be picked up for future projects. So out of the box, 12D is shipped with one, but you can always override the naming convention. And I do suggest you come back and have a look at these. Now I might just drop in a simple left turn intersection, and you can find those under the subdivision here. There's a left turn here that we can drop in there. So I'm just going to turn these models off. Again, turn the curve returns off for a second, and we can just try out different intersections at this point. And I'll introduce you to, I guess, some of the name changes and the model changes that have happened. So you've got the component library there. To simply place them, we come across to the place component, and we give it some information. Again, you can choose out of your library, out of your user library if you wish to, if you have done some changes to the ones out of the 12D shipped options. But if we come in under the subdivision, I'm going to place a simple left turn in here. We need to load in the alignments that will be based off. So the major left on the way in. So again, this is sort of the approach to the intersection. And the departure, I guess the minor road as would be departing down this. That's again is locked in the two center lines that everything's going to be based off, and the direction. How far it's going to be offset from those, any clearances that we want at the intersection there. And this is an important one with the major and the minor approach. It's going to possibly need 150 meters to calculate all the geometry in. Now, if you don't have that, especially down the minor road, you might only have 20, 30, 40 meters, then don't set it to 150. You'd want to set it to the amount that you have. If it doesn't have enough geometry to set, then the component might not actually sit correctly or work out the components, because geometrically it can't solve the answers. I'll have enough room to lock that in. Now, by default, 12D will create a function name, and again, you can rename that. But what's really important, and that's one of the changes they've done for 15, is to use this ID. So if this was, say, an intersection, you were just going to try out what this might be, I might drop in there, this is my intersection, my first one. So I'm just going to put in the the ID of INT1, the intersection type of number 1. I might have a different intersection type I might try after this. Now that's a really important key, putting that ID in, because that will be used in the model naming and also the string naming that's processed now in version 15. You could put a process in. The old model has been left there if you're still using old components out of previous libraries. So you might have changed the naming convention and specified that the strings get generated into that model, so that one's still left there. But with the ones out of the box or the library that's now shipped, they'll actually be split up into their own IDs, and that again came from the user's feedback. I'm also going to put the chain in. You saw the simple chain that I had before, and I'm basically going to quickly output a chain as well. So when I place the component, 12D will come in and place it, and it's done all those geometry elements. They're all super alignments, elements, and computated off the main alignments that we've chosen. Now to have a look at how it's all gone together, we can actually open up the chain. Come across here and hit open, and you can see the little chain that's been built, and in terms of the resolving of one super alignment after the other, the traffic island there, then the curb return string that's been generated, and then some further line marking that's been generated also. So this is the list and the order that the super alignments have been built to form up this geometry. They're all just super alignments, so you can go back and edit any of these whichever way you need. To make it a little bit easier, we can actually come in and change the definition. And as soon as you do this, 12D does say, hey, you're going to go away from the one that was shipped in the library. You're going to change it in some fashion. Are you sure you want to do that? And most likely you do. So we'll hit yes there, and we'll now go in and try to make it, adjust it to our needs. So the placement parameters are still there. And on the left turn here, you can see an important change here in version 15, where we've got the alignment name and the ID number. So the models that are now being generated are alignment and the ID, and line marking and ID, and you can see they're the model names with that INT1, or the first intersection I wanted to build, with that ID number being in place. Then it's got the string name, like reference string for a curb return, again the ID number, and then it has a count number. So if you had multiple curb returns, it would start to count the numbers of strings 1, 2, 3, 4 and such. So yeah, if I do an F2 and have a look at the curb return, it's in a model called alignment with the intersection number 1, and also reference string RSK intersection number 1 and 03. So that's been built in there. So this is the new naming convention for alignments. You'll get the ID at the back, line marking with the ID, and also the construction strings go into their own model as well. I'll show you that in a minute on another intersection that we'll build. But so we can actually build these individually, and the strings will go into their own models, and you can utilize it how you would like. At any time, as I said before, you can come in and rename them. So this ID number, if you didn't want all that, I could just call it RSK99. And as soon as I hit set, it obviously recalculates all the strings. And if I come back F2 and inquire, you can now see that the string name's RSK99. So you can always override these elements that are first placed and rename it to your needs. But out of the box, that's 12D's standard naming convention. Coming down here a little bit further, you can see I've got the high entry curve, which is pretty nice. It's coming in at 70 degrees to our minor road there. But there, as I said, other components, we've got the standard stand-up, which is just a standard curb return, which is pretty boring. It's the one that we could have used the other tool for. It's just doing the fillet in there with the 12.5 meter radius, it looks like, to place the curb return in there. That one's pretty boring. Does the job if that's what you want. Or the free, and you can see here, this one's got a different combination of elements and geometry again, where we've got the diverging lane, and this is how long the diverging lane length is. So you could come in and lengthen and shorten the length that you'd need for your project. There's got some information about the offsets for the traffic island in the middle here. And you can actually click on, for the traffic island, a little image down the bottom that shows you where all the offsets are. Then there's the approach and departure, so you can work out which all your offsets are and your radiuses, and they all match up quite nicely with these numbers and the radiuses that are provided there. And then as we come around the corner, so you've got the diverging, the island in the middle, and then we've got the merging lane information at the back here, so where we merge back in down the side road here. So again, if you needed to adjust any of these lengths, radiuses, or taper lengths, we could adjust all those. These are just super alignment elements. So at the end of the day, you're basically just dealing with the super alignment, and this is a front editor to changing all the parameters that you can change in the super alignment. Let me just open it up and you'll see that it is exactly what we were talking about. Open up the elements, part editors here, and horizontally. Oh, I didn't show you that, but it actually is also vertically solving the geometry for you as well. So it's doing quite a lot of work for you in terms of horizontally and vertically, setting it up, putting it all in, labeling it all up, putting little notes in there for you so it's naming all the geometric points. But again, you can come into any of these if you want to and simply change the radius. If I didn't want that to be 12.5 anymore, I could come in and simply change that to be 15. Hit set, and it would obviously update the geometry as needed. So we're just building these components are just another way to build super alignments, all elements, all computated together. So if any of the main road approach or departure road update, the whole thing can be recalculated through the chain and the geometry will hopefully all solve for you. So that's one intersection for you, just an idea that you could use that one. There's also other options that are available, and I thought we'd quickly show another one. I'll just turn these models off. And the other one I thought we would quickly show might be some sort of a roundabout. Again, got the same sort of elements in terms of the major road and the minor. So I've got my major road coming through the intersection here and the minor road coming down our side road here. Now in terms of the departure, so the major approach, I've definitely got 50 meters, and departing along the major, I've got 50. I have no major approach because there's nothing coming into the intersection, but I definitely have a minor approach. There's no, and I have a minor departure, but I don't actually have any minor approach. So I'm going to put 0 in the answer there because I've got no approach to the intersection. And this is how we can form up a three-legged, I guess, roundabout if you want to. Again, the function name's there, and again, I'm just going to put in this ID. Again, it's really important that we put some sort of an ID number in there because that's going to be used in all the models and the strings that are generated. So placing that in there, let me again just grab the name of the function to generate a chain, and I can place that in there. So if you've ever had to draft a roundabout, you'll probably know how difficult it is or how long it would take you and how quick the 12D will put that geometry together for you is quite unbelievable. It's quite fun to place them in there. If you open up the chain, you can then start to appreciate how much calculation's gone into that, how many super alignments and how they're all resolving off one another to build up the geometry to give you the answers there. Now there's quite a number of strings in there that are just in a model for construction. Actually, I'd turn that line marking one off there. So yeah, you've got the alignment strings that have just come in because of this ID number, and also these construction strings. I can turn those off, as you can see there, and turning them back on, you can see there's got 12D's put some check strings in there for your geometry, also for your roundabouts to match OS roads. So you've got some radiuses in there to check to make sure that geometrically the roundabout's the right shape. But these are all super alignments. They're all computated off one another, and 12D's form them up both horizontally and vertical, so long as the main roads that you've built it off are set up. Again, we can come in and change any of the parameters if you want to. But one comment I often get spoken about or comes up during the training is the fact that these are really nice, these components, but they're just for greenfield sites. And then it's quite quick to realize that if you're feeling fairly comfortable with the elements and the computators and how the strings are put together. Now I've just turned on a survey road string there, and to show you how you can simply plonk one of these into like a greenfield site, but then adjust the strings if you're happy to make it fit your brownfield situation. So I'm going to come in and adjust the curve return here, and we'll pull it apart and we'll actually have a look at it both horizontally and vertically. So I'll come in here and have a look at it vertically. You can see it's being solved there. If I come in and show you the road, there's obviously you'd expect the survey to be up there where the tin is. So horizontally, if we have a look at it, again, if you're understanding the way that the elements run and the way that it's been put together, you'll see that it's just a simple fillet. There's the radius there, so I could come in and simply change the radius if I needed to, increase that or decrease that number. But on the way in, it's actually being calculated off this construction string that's coming through the intersection here. Now, that construction string is just a copy of the center line or referenced off the center line. But if I was to change that and say, actually, let's build it off the survey string, lock it in there, so it's built off the survey string, But obviously building it off where the edge of the road is, I don't need the 3 meter offset anymore for the start. And by hitting set there, 12D's essentially then geometrically locked it onto, in the horizontal sense, onto the survey string. So again, if I update the section view here and just redraw it, you can now see the survey string, and horizontally we've now geometrically, I guess, locked it onto the edge of the surveyed road there. Vertically, we do the same thing. If you're feeling comfortable with the parts, you'd obviously realize that at the start here, we're computated off the top here, come through the points, and we're not going to be getting our vertical geometry off the center line, off our alignment string anymore. No, we want to change that. So it's actually, again, calculated vertically through our survey edge of road string. The slope, well, 0, because it's got no offset anyway. That's fine. And as soon as I hit set, you'll see that vertically it's now jumped up to also vertically match in with the brownfield site or the existing survey string. So these greenfield components can be very quickly manipulated to match your brownfield site. And again, it's going to save you a lot of drafting and a lot of work if you're feeling comfortable with the elements and understand how the components go together. They're really easy to manipulate the ends as you need to and get the geometry to solve. Another help I wanted to go through with these components and the elements, if you haven't used them much, is there's one other tool that's quite useful in 12D off the Super Alignment toolbar. It's under the first drop down here where we've got some Super Alignment help. Now this gives you some information, I guess, horizontally and vertically, and you can see at the moment I'm showing the horizontal, and you can step through these next, and read how all the parts go together. And 12D does give you some examples that graphically on screen show you how it goes together. Vertically, we could do the same thing, talk about the vertical and step through the different parts and try and explain how the geometrical parts go together. But the one thing I really like this is that if you wanted to get a bit more information, showing the horizontal there, I can come and actually read in some examples. And by hitting the read button on here, 12D will create a new section view for me, sorry, a new plan view called Essay Examples, and I'll just place that over here. And yeah, so it's created a brand new model called 12D Horizontal Elements. So we've got a new model with a whole bunch of super alignments. Some are fixed, some are free, some are floating, transition spiral examples, and we've even got some computators down the bottom here. And all these are basically brought in so that you can just edit them and play with them, adjust them as you need to, and just get a bit more understanding of how they all go together. So if I was to edit this one, and you can pull these apart. That's the one thing I really like about these examples. We can actually pull these apart. Sorry about that. Have a look at the horizontal elements. You can see it's got a fixed string there and how it's been set up through the 2 points and the extents that it's been used for those 2 points. So it's chainage 60. So if I was to adjust the chainage 60 here, let's make it, I don't know, 120, and hit set, then obviously it would extend along there before the floated arc would then get placed off the end there. So essentially it's just pushing the geometry back. Now this floating arc through a radius of 180 is often used for noses of traffic islands and things like that. So again, you could adjust the radius and hit set and see how that works. And obviously we're going to a negative, so it's going to the left. If you wanted it to go to the right, obviously place a positive in there and it would go to the right. So all these different combinations, and the really nice thing about this is that it's in its own model. So at the end of the day, when you're happy playing with it and destroying whatever you need to do as you're training on this, we can come in and delete the model out, and there's going to be no harm to your project at all. So that's the horizontal elements. There's also some vertical elements you can also read in and have a look at those vertical elements if you want. And there's another option here where we can actually show you some solutions. And if we step through some of these, 12D is actually shipped with some 12DA files that go through some transitions for spirals, and they're quite handy for railway people, back-to-back spirals and transitions in there. There's the traffic nose and taper compounds that we've got in there, some examples, cul-de-sac bulbs, maybe a high entry intersection. And there's railway loops as well. So these are all super alignments that are computated and just provided as an example so you can pull them apart and see how 12D would go about building this sort of geometry for your civil projects. There's even a whole grade separated interchange. And again, by hitting read, 12D will read this in. It's just another model of an example model there that you can also delete when you wish to. but you're basically given a whole bunch of super alignments, elements, and they're all computated together, and you're more than welcome then to go in and actually start to pull these apart and actually see how 12D has put the elements together to form the geometry up there. So there's quite a lot of information that 12D is shipped with to try and help you out. So definitely keep an eye on that one with the help. You'll only find that on the Super Alignment toolbar. You won't actually find it off the main menu at all. So you'll have to open up the SA All to grab that one. But it definitely will save you a lot of time, as well as the components. The components are also really brilliant in actually dropping in geometry and then moving it if you need to from a greenfield position into a brownfield site. Thanks for joining me today. I hope you got a lot out of the session. There was a lot in there of information, so I do hope you go back and have a look at some of the other training videos as well on either super alignments, the Apply MTF Manager, snippets or chains. These tools all together within 12D will make your designs much quicker, much more efficient, and with updates or design changes as they flow through, will make your productivity much better. So I hope you've got a lot out of this session, and I'll catch you next time. Thanks very much.